Integration by parts is the integration rule which is equivalent to the product rule. So let's start by reviewing the product rule. Basically, if u and v are functions, then we have the product rule, which says that the derivative of a product is computed by taking the derivative of the first factor times the second plus the first factor times the derivative of the second. Now imagine that we're going to take this equation and integrate both sides. Then we get the following. Here we take the derivative and then we integrate, and so by the fundamental theorem that cancels essentially, and we get our functions back, u times v. And then over here we're going to rewrite this as an integral, which I'm going to call v du, and the second thing I'm going to write as an integral, which I'm going to call u dv. And here I'm thinking of that du is u prime dx, and dv is v prime dx. Now, in order to get my rule, the only thing I have to do is I subtract one of those two integrals on the other side. So I'm going to subtract the v du on the other side, and I'm going to write this as integral u dv is equal to uv minus integral v du. And this rule right here is called integration by parts. Now, what does this rule allow you to do? It allows you to replace this integral u dv with the integral v du in the hope that the integral v du is going to be easier to deal with. So let's look at an example of how to do this. So suppose we're going to have an integral of x squared, the natural log of x dx. So now we have to think of this as a product of two functions. And there are various ways of thinking of this as a product, and I'm going to write them all out, and we're not going to pursue them all, only those we want to pursue. So the first one I'm going to write as 1. So we could say u is equal to x squared, and then dv is equal to the natural log of x dx. So that's the first way. Or we can think of this as the other way around. So we think of u as equal to the ln x and dv as equal to x squared dx. Now, there are two more which are maybe not quite so apparent, but we could, for example, think of u as equal to x and dv as x times ln x dx. Or, the other way around, we think of u as x times ln x and think of dv as x. So how do we proceed from here? Well, in order to apply this rule, we need to know what is v, and we need to know what is du. Now, to go from u to du, all we need to do is to compute the derivative. And to go from dv to v, we need to compute the antiderivative. And so I would make my choice which one of those to pursue, now simply based on the fact which antiderivatives are easy to compute. And so I would throw this first one out. Yes, we can compute the antiderivative of ln x, but it turns out in order to do this, we actually need this rule. And this also seems to be difficult. So I'm going to be throwing those two out. So let's assume that I'm going to pursue 2. So u is ln x, du is 1 over x dx, and the antiderivative of dv is 1/3 x cubed, and that is v. Now I'm going to write my rule. So the integral of u dv, which is x squared ln x dx, is going to be uv. U is ln x, v is 1/3 x cubed, so this is 1/3 x cubed ln x minus, and now we have to take v du. So what do we have? We have an integral of 1/3 x cubed, that's v, and du is 1 over x dx. Now, clearly we get a cancellation, so this 1 over x cancels and this remains a square. And then we can see what the answer is. It is 1/3 x cubed ln x, and then this is 1/3 x squared, and so what's the antiderivative? It is 1/3 x cubed times 1/3 is 1/9 x cubed, and then since we don't have any integral anymore, we add the undetermined constant. And so this is the solution. I now will erase the top board and pursue number 4. So next I want to pursue number 4 because the antiderivative there is also easy to compute. So here is 4. So we take the derivative of u, that's a product, so we need to use the product rule. So du is equal to derivative of x is 1 times ln x, and then plus x times the derivative of ln x, which is 1 over x, and this is ln x plus 1. Now, the antiderivative of x is easy to compute, so v, well, I should have put here a dx, and so v is equal to 1/2 x squared. So now we can again write out what the rule tells us. So the integral of u dv, which is x squared ln x dx, is equal to uv. So v is 1/2 x squared, and u is x times ln x minus the integral of v du. So this is the integral of 1/2 x squared, and then du is ln x plus 1 dx. So now we are going to simplify this slightly. So the first term becomes 1/2 x cubed ln x, and then the second term I'm going to write as 2 separate integrals if I FOIL this out. So I have negative 1/2 the integral of x squared ln x dx, and then minus 1/2 x squared times 1, so this is the integral of x squared dx. Now we're going to do 2 things. Here we see we got the integral back, which we started with. But there's a minus sign, so I'm adding this on the other side. So I have 1 times the integral plus 1/2 times that integral. That gives me 3/2 times the integral we want, x squared ln x dx, is equal to, then we have 1/2 x cubed ln x, and then Here, negative a half the integral of x squared, we take the antiderivative, it's 1/3 x cubed times a half is 1/6 x cubed dx. And then we have no integral left, so plus a constant. Now all that's left to do is divide by 3/2 or multiply by 2/3. And so what do we arrive at? The integral of x squared ln x dx is equal to 2/3 times a half is 1/3, 1/3 x cubed ln x, and 2/3 times a sixth, we cancel the 2, that's 1/9, 1/9 x cubed plus a constant. Made an error here, this dx should not be there. Okay, so now if we compare this answer with the answer below, then of course, as in mathematics, we get the same thing. And this tells you that there's often more than one way to arrive at a correct answer. Of course, whatever is easier is the preferred way of doing it, and probably everybody would agree that this too was the easiest way to solve this problem.